This episode is sponsored by Front-End Masters. Engineers have watched over 2 million hours of Front-End Masters videos to upgrade their skills in the latest best practices in front-end development and Node.js. Popular video courses of theirs include courses on advanced JavaScript, Angular 2, React, API design with Node, and functional and asynchronous JavaScript. Many of their teachers have even been guests on JavaScript Jabber. Check them out at frontendmasters.com.
Hey everybody, and welcome to episode 251 of the JavaScript Jabber Show. This week on our panel we have Aimee Knight.
Hello.
I'm Charles Max Wood from devchat.tv, and this week we have a special guest, and that is Kim Carter.
Yep, my name's Kim Carter. As Charles just said, I'm a software engineer. I do quite a bit of architecture. I do security in many different areas. A lot of web security and network security, web applications, you name it pretty much, I'm doing. And I'm currently working hard out on the second fascicle or volume of a book series called Holistic InfoSec for web developers, and also running or basically organising a couple of conferences. So I've got the OWASP New Zealand Day coming up soon, and we've just had the Christchurch Hacker Conference that ran near the end of last year, and sort of organising that again for the end of this year. That's kind of me.
Makes sense. Now, we've been emailing back and forth about maybe reviving web security warriors, and it looks like you do a whole bunch of InfoSec stuff, especially for web developers. One thing that I'm kind of curious about, just to kick the conversation off, is it seems like most web applications that I know people that work on them, most of the front end devs don't really worry too much about it. It's all on the back end, and oh boy, can somebody get in, hack our API, or can somebody get into our database or something? Is this something that front end developers need to worry about?
Yeah, it is. Yep. So I mean, it really depends what it is you're building, right? I mean, a lot of the time, most of the security concerns are in the back end. That's sort of like, I guess, where the buck stops. But there are things in the front end that you can do, especially around a usability and that sort of thing. Like sanitization, input sanitization, filtering, and validation and that sort of thing, that actually provides a better user experience and basically bakes some security in the front end, so that it doesn't have to make full round trips to the back end. So you can actually sort of attack your address security issues in the front end before the back end even gets to see them.
That makes sense.
So yeah, it is definitely a thing for the front end as well. And I mean, there's quite a few front end sort of exploits coming around now where you can actually attack things on your devices and that from the web browser. I mean, like one excellent tool is the browser exploitation framework. So you can basically break into a network through the browser using those sorts of tools and add persistence and traverse the networks and, pretty much own, or at least get to a place where you can start to kick off other exploits on people's systems and start to traverse the network. But that's all based on coming in through web applications through the front end.
Oh, really? That's interesting. Yeah. I didn't know that you could do all of that stuff from the browser. I mean, I just try and stay on websites that I think are safe. But you don't hear as much about those kinds of things where it's they can hack your network and things like that from the browser. I mean, most of the time when you're talking to people about being safe on the web, it's like, don't go to bad sites or you'll get a virus.
Well, yeah, that's true. But see, the thing is, a virus can do anything that the author wants it to do. I've just been working on some Windows exploitation via PowerShell. So basically, once a user activates a virus, that virus can do whatever the creator has designed it to do. So in terms of like PowerShell, which is what I've just been working on, you can so because Windows trusts PowerShell explicitly. PowerShell is an excellent attack vector to actually break into people's systems and networks and add persistence and traverse across networks. And it's actually very easy to do. And in most cases, you can bypass antivirus because a lot of the times what you do is you actually basically you give your target a virus. They run the virus. It could be like an Office document or some sort of an executable if they have enough trust in you. Otherwise, just an Office document or something that's going to basically catch their attention. And so once they run that, that can basically pull something down, like pull a hosted payload down, and then that can run in memory and do all sorts of things in memory and completely bypass antivirus, because the thing is the payload is encoded and antivirus is looking for specific signatures, and those signatures are really easy to change just by changing the PowerShell a little bit and then encoding it again. And then once that payload is run, the antivirus doesn't see it. And also it's not hitting disk, it's not being saved to disk. So you can, antivirus gets pretty anal when things get saved to disk that it doesn't know about or that it sees as being dodgy based on their signatures. But if it's not saved to disk, many times you'll get past antivirus.
All right. Well, let's go ahead and back up and talk about some of the more common or basic things.
Yep, that's kind of what I was hoping is if you could maybe give us like a rundown of, it's 2017. What are the most common problems that you see are still vulnerabilities for people?
Yeah, so normally the first place an attacker will get into your system or your networks is via your staff, is via your people. Most attacks are coming via getting to know someone or like phishing attempts and that sort of thing. So people are still clicking on links and emails. People are still running Office documents that have been passed to them or that have been put in a public place that they can run, and then that executes some code on their machine. In most cases, the most successful attacks are started at least by social engineering. We've got 0 days and that sort of thing, and they are still being used, obviously, but they're expensive because you've actually got to find exploit and code, a new one that no one else knows about, and it takes some work, or you've got to basically buy one off the shelf, sort of thing.
So let me define a couple of terms here. So the first one is social engineering, which is when a hacker or a third party basically gets to know somebody or builds a relationship with and then exploits somebody to gain access to a system. So they'll talk them into giving them a password or something like that, either by posing as a coworker or something like that. And then a 0 day is an actual exploit in the code that hasn't been discovered and disclosed. So it's been discovered, I guess, but not disclosed.
Yeah, exactly. So it's been discovered, and no one else knows about it other than the person that's discovered it, essentially. Yeah. The other way is passwords, is basically just simple password stealing or password guessing. That is still one of the most effective ways of breaking in, because it also doesn't leave a dodgy audit trail, because it just looks like a legitimate user has logged in and done whatever they've done, and then basically the blame ends up back on the user.
Right. They failed to type in their password properly, so it didn't work.
Yeah,
that's what it looks like to the system.
It did work, but the attacker has taken things further. So once you own an account, that gives you a launching ground to get system privileges if that user hasn't already got them. I mean, often it's good. It's nice to be able to target domain admins and that sort of thing. But if you haven't, if you can't get access to that person's user account, then you can try all the low privileged accounts in the organization. And of course, we've got LinkedIn now, so you can build up a pretty truthful organizational hierarchy of what the organization looks like. And then you can, I mean, with all our social media, you know what people are into, what spins their wheels and that sort of thing. So it's generally fairly easy to launch a social engineering attack of some kind and build trust with your targets before you start asking them to do things.
So what you're saying is you can essentially start out with guessing passwords. So you get access to a low-level account, and then you go on and you find out who the system engineers are, the people that have higher privileges than you. You figure out, what, they like the Broncos and they are having a Super Bowl party at their house on Sunday. And so you call up and you say, hey, I know the Broncos aren't in the Super Bowl, but blah, 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 to put them at ease. Oh, and by the way, my low-level account that I hacked is having this issue. Can you blah, blah, blah? And then you start to collect information and, eventually get enough information to get access to their account, and then you have higher privileges. Yeah.
So basically what we've got is we've got two fascicles in the book series that I've been writing currently. So I've got the first one, which is got the first two chapters, which walks through the 30,000 foot view, because we try and get developers back to a 30,000 foot view, a nice and high level, so that they can think holistically and start thinking about all the possible attacks that could come against them and their organization, because generally developers are really focused on what they're working on currently. So we tend to get tunnel vision. So basically I get the developers to step right back, and then I go through setting up a team, like a team structure of what works best in a Scrum team, and with baking security into it. So that's in the first chapter. And then I take the team down to a 10,000 foot view. So we get them to start taking what they've already learned down to a lower level, and then start to focus in again, and then continually getting them to step back as well, because we just keep getting boxed into our tunnel vision. We don't see what's happening around us in terms of security and in the world. Then I go into the tooling setup. So what happens here is I get the developers and development team to set up a penetration testing distribution. I add a bunch of tools and go through how to configure them and that sort of thing. So we've got a Linux attack box, and we've got a Windows box, which we use for basically just compiling some things and some PowerShell attacks and that sort of thing. And then we go into the physical chapter and the people chapter. The physical chapter and the people chapter are the first topic chapters of the book. And then basically the next fascicle, or book if you want to call it. So the fascicles are a logical term for breaking up the book. So I've got three sort of separate books, kind of, but they all make one book. And the reason I broke it up is because it was just going to take too long to write the whole thing, because there's just too much in it. And I wanted to basically get releases out so that people could start to get good content out of it, and I start to get educated.
That makes sense. Can I stop you here for a second? Because you're kind of talking about your approach, and what I'm wondering is you start at the 30,000 foot view, and you start at kind of setting up the team. What I'm wondering is, what do you have to know at that 30,000 foot view? I mean, what are the basic things that people have to just start with in order to start being effective with InfoSec?
I'm kind of interested too, we talked about social engineering, but what are some front end specific things that people would want to look out for?
Yep. So all the front end stuff is pretty much in the web applications chapter, which is the last chapter of the two fascicles. And the reason I put it at the end is...
Could you get into those examples?
Yep. But just before we do, the reason I put it at the end is because we take a lot of that stuff for granted, and we should already know about those things. It's all the stuff leading up to that we often don't know about and should know about. Mm-hmm. Does that make sense?
It does and it doesn't. I mean, it makes sense that there are things that we're going to need to know going into this, but at the same time, it's like I guess my thinking is yeah. I mean, if there's some exploit or some something that I should watch out for as a front end developer, then why put it at the end? Why not just say, hey, make sure you're doing all these things, and then come back around to okay, and then here's the other stuff you got to know.
Yeah, so basically it's because most people think that, like the front end is where organizations are getting attacked the most, or like web developers think about, the front end code that they're writing is how their organization gets attacked. But 9 times out of 10, it starts within their organization with their people. So they need to sort of think about all the social engineering attacks and that before they even start to think about the web applications. But then, if they're not interested in that, then there's still quite a chunk of material in the web applications chapter. So some of the stuff in the web applications chapter is, let's have a look. So we've got lack of visibility, which is basically insufficient logging and monitoring. We've got lack of input validation, filtering, and sanitization, which covers the likes of buffer overflows, cross-site scripting, cross-site request forgery, SQL injection, a NoSQL injection, command injection, loads of different injections in there. Also, a lot of the stuff in the web applications chapter, OWASP already covers. So it's like I'm covering a lot of OWASP material, and then I'm adding quite a bit of stuff around that as well. But web developers should already know about it.
So this is something that I think is interesting. You've hit a whole bunch of stuff that I kind of want to unpack here, and I think talking about the technical end and then talking about the people and organizational end, I think is also really interesting. Just because, we all assume that we're smart enough to not fall for this, but then it's the assumptions of where we're safe that really pull us apart. But let's dig into the technical end of things, and then let's circle back around to the people end of things. So one of the things you mentioned was logging, and then the other thing you mentioned was OWASP, and people should know about this. And I didn't even know what OWASP was until I'd been a developer for like 6 or 7 years, and somebody finally said, that's the security kind of important stuff. So, do you want to talk about OWASP first? Because I think that's a resource that a lot of people should know about, and then I want to come back around and talk about why logging, which is so interesting, right? It's the most interesting thing we do as programmers. No, it's not. But why is that so important? So start with OWASP.
So OWASP is the Open Web Application Security Project. So basically, this is an excellent resource for developers and penetration testers. So they allow chapter leaders to run conferences in their country and that sort of thing. So we have the New Zealand chapter, and we run an annual conference, and we run regular meetups and that sort of thing. Basically just getting people along and educating and just providing a good place to discuss issues for developers and engineers. So that's kind of OWASP in a nutshell. I mean, they've been around for quite a while, and they do a lot, and they have some excellent resources. Also going back to the processes and practices chapter, we build up an agile development and practices sort of set so that as a developer within your team, you've got a bunch of things that you can work through, and this all becomes part of your Scrum definition of done. So the idea is that by the time you deliver your solutions, penetration testers shouldn't have to be testing for the OWASP top 10. So the OWASP top 10 is 10 security, not only defects, but areas. So it's 10 areas of web application security that are rated to be the top 10, right? The worst ones, or the ones that we keep making the same mistakes with. So as developers, we keep introducing these things, right? So our SQL injection, I think it's still number one. It's been like a number one for like years, or it's been in the top 10 for about 10 years. So we're just not learning, right? And SQL injection is really easy to mitigate.
Yeah. So yeah, SQL injection.
Yeah. So the idea.
It's usually
the
just
idea
built
is
in. The filtering is usually just built in. Anyway, go ahead.
But the idea is that the penetration tester, once they get hired in, which is often at go live or at the end of the project, they shouldn't have to be still finding OWASP top 10 defects. They should be working on the hard defects that the web developers haven't found, right? The development team should have already addressed all the top 10. And these are the simple things, but still we're seeing developers aren't even aware of them, right? And that's the whole idea of the book, is to basically open people's eyes, take them back to the 30,000-foot view to start with, show them everything that can go wrong, or as many things as possible that can go wrong, all in an ordered sort of structure. And then sort of at the end of it, say, right, this is the web applications chapter, after we've looked at all the other chapters, which is networking, VPS, people, cloud, and a bunch of other chapters. So then we dive into the web applications chapter, which has got a whole lot of things that they need to, as developers, need to start thinking about as well when they're writing code.
Let's take a break from this episode and really quickly talk about finding a job. Searching for a job can feel stressful, scary, and time-consuming. Pushy recruiters try to sell you on roles you don't actually want, and the job boards make you feel like you're throwing your resume into a black hole, never to be seen again. And sometimes you go all the way through an interview process just to find out that the very end that the salary offer or company culture doesn't match what you're looking for. Well, there's a solution. Hired.com is the world's most intelligent talent matching platform for full-time and contract opportunities. They make the job search faster, focused, and stress-free instead of endlessly applying to companies and hoping for the best. Hired puts you in control of how and when you connect with compelling opportunities. And after completing one simple application, top employers apply to you. And the best part is that you get money. That's right. They pay you if you get a job through them. Listeners to this show can earn double their normal hiring bonus by signing up with the show's link. That's right. You get $2,000 instead of $1,000. So go sign up at hired.com/JavaScriptJabber.
So how do they find out what the OWASP top 10 are? Because, again, I mean, I've heard of OWASP. I occasionally drift over to their website. But it seems like, Aimee's asking what are the most common or most hairy, most scary things out there. And it seems like OWASP has already identified them. So how do people find those?
Yeah. Well, they're not actually the most scary. They're just the most prevalent.
Oh, okay.
Yeah, that's kind of like I was thinking, because we like to keep this podcast kind of open to people of all skill levels. So, I have only been doing this a few years. So I'm trying to think, like, for developers who are new, what is there something that they should be keeping an eye out? And are there basically like, what are the most common things? And then my other question was going to be like, is there any like low hanging fruit that just like would be basic competency for anyone?
Definitely. So that is the OWASP top 10. So that is the really low hanging fruit. So these are the mistakes we keep making year after year, and they are the most common mistakes. That's why they're the top 10. So yeah, if you just Google OWASP top 10, 2013, they're working on another one at the moment, but 2013 I think is still current. So number one for 2013 is injection, right, which covers a whole lot of different types of injection attacks. And then we've got number two is broken authentication and session management. And then number three is cross-site scripting. And we've got a few others down past that. But yeah, they are pretty much the ones that we should be looking at to start with to make sure that they aren't in our application.
So a lot of these are, the ones that we've known about for years. There's really nothing new.
Pretty much, yeah. Yep. They're pretty much your bread and butter for a web application developer that they should already know about and shouldn't be struggling with. And once the penetration tester gets his hands on the application, there shouldn't be any OWASP top 10 issues that still exist.
One thing that I think is interesting about the things that you listed, and Aimee's saying, yeah, those are things that it's nothing new, it's old news, but at the same time, a lot of people still miss it. I mean, that's why they're talking about it.
Yeah.
The other thing that's interesting about it is that a lot of the modern web application frameworks, I mean, Ruby on Rails does it. I think Express does a lot of this stuff. They have tools in there to mitigate a lot of this stuff. So it's really just comes down to using your tool properly, not necessarily.
Yeah. In many cases, that's true. In the likes of Node.js, we've got a huge ecosystem in NPM now, and many of those packages do not take security seriously, and there are issues in there. And that's why we've got the likes of the Node Security Project and Snipe and that going hard out.
So how do we get, this is another thing, how do we get our open source contributors and authors to take security seriously?
Yeah, so there's a section in the Web Applications chapter around that called Consuming Free and Open Source. So I've listed that as a risk, and then I've got the countermeasures for that. In terms of getting the actual authors to take it seriously is pretty much the same as getting our development teams to take it seriously. I mean, we're all in the boat of being software engineers, right? Whether we write the code for ourselves or whether whether it's closed source or whether it's open source. So basically just got to learn about our mistakes and stop making them.
All right. So how do we get our teams on board? Like how do we get teams that are thinking about this? Because, most of the development teams that I've worked on, it basically boiled down to, hey, we're going to use the framework, and hey, we know that it has all these features that, avoid these top 10 issues.
Yeah. So in the Consuming Free and Open Source section, in the countermeasures, there was an excellent podcast noted an excellent podcast by Debbie Edwards from IBM, and she discusses some really good initiatives that they take on setting up some process that allows their development teams to still move really quickly, but they've got like a list of all the packages and that the development teams can consume.
Mm-hmm. So
and then a set of processes and that IBM use in order to critique packages. So they've got a selection of packages that development teams can consume. And if the development team decide, we don't have any packages already that we can use for this specific task, let's look at this one. And then they've got like a set of steps to go through to start critiquing that actual package and basically get it into the list of allowed packages within the organization.
So when they're evaluating these, are there specific tools that they use? It sounded like you mentioned one or two, or is it just a certain set of techniques that you run through and go, okay, I'm going to look for this, I'm going to look for that, I'm going to look for the other?
Yeah, so it's a bit of both, right? So there's a section in there called Consumption is Your Responsibility, and I've got some just some techniques about how you can look after yourself and what not to run and what to look out for when you're installing stuff and that sort of thing. The likes of doppelganger packages, right, which are packages that are named very similarly to other packages. So if the developer makes a typo or something, they could be pulling down essentially a malicious package that's been added to the registry. There's been a lot of malicious packages that have actually made their way into NPM. So we've got whitelisting, so you can whitelist packages in NPM Enterprise, and then the likes of tooling. We've got quite a bit in there. We've got NPM outdated, NPM check, David, retire JS, require safe, Bithound, Node Security Platform and Snike, and there's probably others coming out as we speak. So there's a lot there that can actually help us to increase our security.
So kind of switching topics, you put in the show notes a bunch of different posts, and I was just taking a look at one, and I know I'm familiar with like having to put captchas on a lot of things, especially like for, only for the front end. But what you, in this post, it talks about there's actually like some vulnerabilities for that. Do you want to talk about that a little bit?
You mean vulnerabilities for captchas?
Yes.
Okay.
Because we put them on our site thinking that they're a good thing. So are there downsides to them?
Yeah, right. So basically the downside is that it annoys users, and users shouldn't have to jump through hoops because it's not their problem. Security of the website is the problem of the website. So that sort of thing should be invisible to the user. So I've got a wee example in there of something that I've done, because I did quite a bit of research on this too. And so I just created a wee bot pot, right? So which is just a hidden input field. So basically the message gets through if that bot pot is not populated. So what you can do is you can hide the bot pots, either using just a hidden field or some CSS, so the end user doesn't see it. So it doesn't, to them it doesn't mean anything. It's only there for the likes of bots that go through your website, so filling out all the forms. So because it's hidden, they'll go along and put a whole lot of stuff in there, and then when it gets to your server, you check whether there's something in there, and if there is, then you log it and ignore it.
Right, because the program or the bot is going to look at the form, and it's going to look at the code, specifically the HTML or the DOM, and it's going to see that field and fill it in, whereas a normal user wouldn't.
Exactly. And for me, I've used it on my website, and I haven't. Should I say it's worked basically 100% of the time, and I've been watching the logs, and so it works, and it doesn't annoy users.
I'm going to use Chrome Developer Tools, and I'm going to send you a message in one of those fields now. So I want to. So by putting captchas on, other than annoying users, are there security downsides to that, or is it just that they're ugly?
Yeah. So from memory, there were some of the vendors that were doing some fairly nasty stuff. I discuss it in my book. I don't know whether I should say who they are on the podcast or not.
Public shaming. That's up to you.
Yeah. Yeah, no, I won't, but it's in the book if you want to check out who they are.
So I want to go back to the idea of training teams to think about this. Because most of the time we get in, we kind of bang around, we get stuff to work, and then we just release it.
Yep.
So how do we train our teams? How do we make this part of our process so that when I'm building a new feature and I decide, okay, I'm done, that it's actually done, and I'm not going to have to come back and solve a major problem that I've exposed somebody's data or given somebody an attack vector or anything like that?
Yep. So I've got a bunch of processes and practices in the Chapter 4 under the Agile Development and Practices section, which basically helps your development team to lift their security. So we've got the likes of evil test condition. Actually, I probably should start off with establishing a security champion. I think that's probably one of the most important things. So establishing one of the developers within the team as a security champion. So it becomes their job to mentor the others and to get up to speed on security issues themselves. So I think once you've actually established a role like this and allowed the engineer that you think would be best for it to basically take that role on, and they're running with that role. I think once that's actually happened, then they can start to go through and basically make sure the team, or coach the team to do the other processes and practices. And some of these things are the likes of evil test conditions, right, which are just test conditions, which we often do within a Scrum team, but thinking about it from an attacker's perspective. Often developers are not thinking about how their worlds are going to be attacked. So the security champion there can sit with the team as they're doing the test conditions and help them build up those evil test conditions. So I also address the cheapest place to deal with defects. So often what happens, right, just as you mentioned, Chuck, like we wait to the end of our development cycle, like go live comes along, and then we throw the project over the fence to the penetration testers, and they find all the defects that we should have found, all the simple stuff, and they don't have time to find the stuff that the real attackers are often going to find as well, which is a problem. So what we do is we pull a lot of the security work up front to within every sprint. So we've got the cheapest place to deal with defects there, which is where I address where the cheapest place actually is, and it is within every sprint. So we've got a security-focused TDD. So, and we've got another one that's TDD.
TDD.
So,
okay.
Yep. So you're driving. Essentially, it's regression testing. So what happens is what I've used the ZAP API, which is an OWASP product. It has a large collection of known vulnerabilities and exploits for those vulnerabilities baked into it. It's an HTTP intercepting proxy, a little bit like Burp, some of the others. There's quite a few of them there. So it's a little bit like that, and it has an API, and you can program against it. It's got so we've got a Node client for it, we've got a Ruby client for it, we've got a Python client for it, we've got quite a few clients as well, so you can just pull those into your project, into your test suites. So what happens here is you write your tests, and you basically just tell Zap to attack your application. So the first thing you need to do is actually proxy some requests through Zap back to your web app, and that builds up the sites tree within Zap. So Zap knows what your web application looks like, and then you basically just issue different types of requests and different types of different types of requests on how Zap can attack your web application. So it can attack your web application in quite a few different ways, and it has, like I said, a large collection of known exploits that it can attack your web application with. So you're basically just telling it to attack your web application. So what I've done is I built up something like that, and I put it into a nightly build. So the developers are working away during the day, adding features, and then they come back in the morning and they get a report from Zap that they've got a bunch of someone's introduced some defects, and it'll show you where the defect is. It'll show you the attack that Zap used, and so you can go and reproduce that attack, and then you can go and fix it. So it's things like that basically bring finding the defects right up front, because often that sort of job is done in the penetration testing stage at the end of a project. So we're bringing that right up front. You're saving huge costs because you don't have to unwind all your stack to find where the defects are. So, so let's go live, right? And the penetration tester finds a defect and then passes it back to the development team. Well, the development team then has to get their heads into the space of where they wrote that code, and that can often take hours to get to the point where they actually remember the code that they were writing in order to work out the relevance of the defect with the code that they were writing. So if we can add that into a nightly build, then the developers come in the next day and it's all fresh in their minds, and then they can go and fix the defects as they're introduced. So it's much quicker, and that's how it saves so much money. then we've got the likes of code reviews, and there's some steps in there on like how you can do better code reviews. So we've got dynamic analysis and linting, and techniques for asserting discipline in inherently undisciplined languages like JavaScript. So we can add things like a static type checking, which is essentially the implementation of design by contract, or DBC, for those architects. Peer programming is also a good one, especially if you've got someone that's sitting beside you that has got a security focus. So that's where the likes of a security champion can sit with another developer and peer program. And then the goodness that a security champion has learned quickly rubs off on the developer that he's pairing with.
So
there's quite a few things there that you can actually add in.
Cool. Well, it sounds like the book's kind of a good place to go if you're looking to figure out how to build security into your processes and apps. It also feels like we spent 45 minutes or so talking about something that you could easily spend hours and hours and hours digging into. So maybe we could talk about this later. I know we've also been talking about maybe reviving web security warriors. So that's something also we could talk about. If any of you out there have a feeling about any of this, I'd love to see comments on the website. So anyway, I don't think I have any other questions. Do you, Aimee?
Nope, I'm good.
All right. Well, if people want to check out your book, Kim, or hire you to solve some of these issues for them, where do they go?
So my book's currently on LeanPub. I can leave a link in the show notes if you want. Mm-hmm. And my website's just binarymist.io, and I can leave a link in the show notes. All
right. Well, let's go ahead and wrap that part of the show up and head into our picks. Aimee, do you want to start us off with picks?
Sure. So the first one I have is something that I saw tweeted, but it looks pretty good. It's another GitHub list of a ton of different resources, but this one is specifically computer science video courses. So I will put a link to that in the show notes. It has almost 9,000 stars. So, and I've kind of scrolled through some of these. They look pretty good. So this would be a good thing to start if you want to read up on that stuff. And then the other one, not so programming related. I think I learned about this Twitter account from my mentor, but I follow it on Facebook, and it's called Tiny Buddha. And although I am not Buddhist, there's just a lot of wisdom in a lot of the stuff that this whatever thing is posting these tweets. It's probably some kind of bot or something. But there's a lot of wisdom in them. And so it's a nice complement to all of the tech stuff that comes through my feed. And then, of course, all the political stuff that is coming through lately. So it's just a nice little reminder in there. That is it for me.
All right, I'm going to jump in with a couple of picks here. The first one is, and I think I've mentioned it on the show before, because I went to CES and I talked about the desks, but I just switched my desk over. I had a big modular, kind of like a cubicle, almost exactly like a cubicle kind of desk in my office. It took up more than half the room, but I got rid of it, and I got some of the motorized sit-stand desks. The brand I went with was autonomous.ai, and I got the cheap model, not the kind with the AI in it that figures out what your habits are and goes up and down it yourself. I guess I'm just not so lazy that I can't just hit the button myself. But anyway, I'm really, really digging it. Nice desks. The other thing is that it allowed me to consolidate. I had an IKEA Lifehacker standing desk set up sitting on top of my desk on one end, and I had a monitor set up over there and a monitor set up where I sat, and then I would just move back and forth with my laptop. And so I've been able to combine it all, and now I have this 4-monitor setup, and anyway, it's pretty nice. So I'm pretty happy with all of that stuff. So I posted a picture to Facebook. I don't know why my phone wouldn't post it to Twitter, but it wouldn't. So anyway, yeah, I've got piles of stuff that I pulled off of my desk in my office now, but yeah, we're getting it all rearranged. It's been pretty nice. So I'm going to pick the autonomous.
They're pretty
desks.
expensive, aren't they?
I got their cheapest model, and I think they were like $300 a piece. So,
Okay.
So if you're buying them on your own, I mean that's fairly reasonable, but it's not like an impulse buy cheap. So, anyway, I'm really liking them, and then yeah, I think that's all I'm going to pick this week. Kim, do you have some picks for us?
Yeah. So summer. Summer's my first pick. 25 to 30 degree days is definitely good for pulling you out of the spring and winter and that sort of thing. Just been really enjoying like having doors open in the office and just so much heat coming in. It's just been really nice. Second pick would be my coffee machine and grinder. So I've got a BBMA Doma Bar Super Lever and a Mazza Mini sitting about 3 meters away from my desk, which gets a lot of use. So that sort of helps me. I get through long days. So I'm a contractor and yeah, basically do a lot of day work and then a lot of night work as well. So it's good for keeping me awake, and you can brew delicious coffee with it. Our third pick would be the Christchurch Hacker Conference, held in Christchurch, New Zealand. First time was last year, and we'll be running that again at the end of 2017, probably October, I would think. So yeah, it was really good last year. It was we got 100, just over 100 people in this cramped up lecture theatre, which had this is probably not very good advertising for it, but the air conditioning, basically there wasn't any in that little room, so people were sweating quite a bit. So we're going to be finding a much nicer room for this year, and people are looking forward to it, so should be good. And a lot of good talks happened last year and should be the same this coming year. That's it for me.
All right. Well, yeah, I already asked where people can go to find your stuff, so let's go ahead and wrap this one up. Thanks for coming, Kim.
Cool. Cheers.
Catch everyone next week.
Hey everybody, this is Charles Max Wood. I just wanted to talk to you really briefly about JS Remote Conf. We just picked speakers. Things are looking really good, and we're really excited to cover a broad range of topics for JavaScript developers. So if you're looking to learn things about Node.js, about becoming a better developer, about deployment, about mobile development, and much more about JavaScript, then come check us out at jsremoteconf.com. You can also find it by going to devchat.tv/conferences and then picking the conference you want. We have last year's recordings there. We have this year's conference coming up, so make sure you get your ticket, and we'll see you there.